Hey everyone, and welcome to The Explainer. If you've ever felt like cloud networking is just this impossibly complex web of rules and jargon, you are definitely in the right place. Today, we're going to pull back the curtain on the absolute bedrock of Google Cloud, the Virtual Private Cloud, or VPC. Seriously, whether you're studying for that Pro Architect exam or you just want to build your cloud projects with confidence, this one's for you. Let's dive in. So let's just start with the most basic question, right? You've got access to Google's incredible planet-spanning infrastructure, but you need your own private, totally isolated space to run your apps securely. How in the world do you fence off your own little corner of the cloud? Well, that's the exact problem a VPC was invented to solve. And the answer is the Virtual Private Cloud. Honestly, the best way to wrap your head around it is with a simple analogy. Imagine Google Cloud as this massive, continent-sized piece of land. A VPC is you showing up and fencing off your own private plot. And inside that fence, you get to decide where the roads go, where the houses get built, and who gets the key to the front gate. It is your own secure, private chunk of the cloud. So here's our game plan. First, we're going to cover the core building blocks, the absolute essentials. Then we'll get into how to direct traffic around your network. After that, we'll look at how to connect different networks together, and we'll wrap it all up with some killer tips that'll give you a real edge on that Pro Architect exam. All right, let's jump into our first section, the core building blocks. Think of this as the foundation of your cloud network. These are the must-know concepts that literally everything else we talk about today is going to be built on. Okay, so the very first choice you're going to make when you create a VPC is between auto mode and custom mode. Now, auto mode is pretty handy for just kicking the tires because it automatically sets up a subnet for you in every single Google Cloud region. But for any real-world production setup, you're going to want custom mode. It gives you complete control to define your own subnets, your own IP ranges, which is absolutely essential for good security and network design. Now, this right here illustrates a super important concept. A Google Cloud VPC is a global resource. It can span the entire planet, just like you see here. The subnets you create inside of it, though, those are regional. So this company has one global network, but they've carved out specific zones in the US, Europe, and Asia. And what's so cool about this is that their virtual machines in all these different regions can talk to each other privately, using their internal IPs, almost like they were sitting right next to each other. And inside those subnets, your machines get IP addresses. Internal IPs are for talking inside your private fence. External IPs are for talking to the public internet. But the real magic, the thing you really need to know about here, is private Google access. This lets a virtual machine that has only an internal IP address securely reach other Google services like cloud storage or BigQuery without ever having to go out onto the public internet. From a security perspective, that is a huge, huge win. All right, Section 2, directing network traffic. So we've fenced off our land, we've built some houses, RVMs. Now we need to build the roads, the highways, the back streets that tell all our data how to get from one place to another. And those roads? We call them routes. It's really that simple. A route is just a rule. It says, hey, if a packet of data is trying to get to this destination, you need to send it to that next hop. It's basically the GPS for all your network traffic. And you've got a few different kinds of routes. You automatically get a default route, which is just for sending traffic out to the internet. Then you can create static routes yourself. A common use case for that is to say, hey, all traffic that's going to my on-premise office needs to go over this VPN tunnel. And finally, you have dynamic routes, which are learned automatically, usually when you have a big-time connection to your on-prem network, like Cloud Interconnect. Okay, let's hit our third section, connecting separate networks. So what happens when you have more than one VPC? Maybe one for prod and one for dev. You've basically got two separate private islands. How do you build a secure bridge to connect them? The most common way you're going to build that bridge is with something called VPC peering. This sets up a direct, private connection between two VPCs. It lets machines in both networks talk to each other using their internal IPs, and all that traffic flows securely over Google's private backbone. It never, ever touches the public internet. And you can keep going with this. Let's say we also need to connect VPC-B to a third network, VPC-C. No problem, we can set up another peering connection. And now VPC-B can talk to both A and C. Seems pretty straightforward, right? Well, there's a catch. And this is a big one. Peering is non-transitive. You really have to get this concept down. Just because A is paired with B and B is paired with C, that does not mean A can talk to C. There's no automatic path that just flows through. If you need A and C to communicate, you have to create another separate direct peering connection right between them. Now, for bigger companies, there's another approach called shared VPC. So instead of peering a bunch of different networks, you create one central host project that owns the main VPC. Then, other service projects, say for different teams or apps, can just attach to it and use its subnets. This is awesome because it centralizes all your network admin and security, which is a massive benefit when you're working at scale. Okay, final section. Let's talk about what separates the pros from the rookies, especially for those of you who have your eye on that professional cloud architect certification. These are the advanced patterns and little gotchas that pop up all the time in those tricky exam questions. Let's start with a golden rule. Seriously, you might want to write this one down. If you see an exam question where two VPCs need to connect, but, and here's the key, their internal IP address ranges overlap, VPC peering just won't work. The answer you should be looking for, like 99% of the time, is Private Service Connect. So here's why. VPC peering, as we saw, needs unique IP ranges. But Private Service Connect, or PSC, is designed for a totally different model, a consumer-to-producer relationship. It uses something called network address translation, or NAT, to basically rewrite the IP addresses behind the scenes so it doesn't matter if they overlap. Think of it as a secure one-way street from a consumer to a service they need to use. Next up, network tiers. The exam loves testing your ability to choose between performance and cost. So Premium tier sends your traffic over Google's super fast private global network for as much of the trip as possible. It's blazing fast, but it costs more. Standard tier, on the other hand, kicks your traffic out onto the public internet much sooner. It's cheaper, but the performance is less predictable. The right choice completely depends on what your application needs. Remember private Google Access from earlier? Well, it actually comes in two flavors, and it's really important not to mix them up. The standard version is for your VMs that are running inside GCP. But then there's PGA for on-premises, and that's for your physical servers in your own data center. It lets them reach Google APIs securely through your VPN or interconnect, again, completely bypassing the public internet. And finally, let's circle back and actually solve that non-transitive peering problem. In a classic hub and spoke design, how do you get two spokes to talk to each other? The answer is to put a network virtual appliance, which is just a fancy name for a router or firewall VM, in the hub VPC. Then you create custom routes in your spokes that say, send traffic for other spokes to the NVA, and the NVA just forwards it to the right destination. It's the classic pro-level pattern for getting that transitive routing to work. So there you have it. We've gone from the basic building blocks all the way to some pretty advanced architectural patterns. The VPC is your private, secure canvas inside this massive global cloud. You've got the blueprint now. The only question left is, what are you going to build?